All right, so what we're going to be doing in the next three lectures is pretty briskly going through the history of psychology. And I really have a couple of goals in doing this. One of which is to really show you the tension that psychology has in terms of its scientific merit, to be quite honest with you, and how that tension has actually led to, in a sense, psychology having what we could think of as multiple personalities. There's kind of two distinct approaches within the field of psychology. So I want to highlight that, the sort of clinical approach, and then the more traditional basic research scientific approach. And I want to use the history to do that. And specifically, I want to use Sigmund Freud because I really see Sigmund Freud as critical in terms of creating this multiple personality, as it were. So the next three lectures are therefore split into the history of psychology before Freud, then a discussion of Freud himself and the impact he had, and then finally a discussion of psychology after Freud that'll bring us in a good position to talk about current psychological findings. All right, so let's jump in. All right, psychology before Freud. Well, I want to begin here by just giving you the context in which psychology was born, because I think that's an interesting part of the story as well. Psychology was born in Germany. A lot of the names we're going to be talking about today are German names. The first psychologists were German. And the reason for that is because we're going to be talking about a period in the late 1800s. And this is a period when Germany was economically a very, very strong country. Okay, they were the strongest country in Europe and in fact, in a sense, in the world. And like many countries who are experiencing a really strong economic time, they decided to reinvest some of their money into research to kind of stay at the leading edge, to give their people the best quality of life, but also to be leading the world in issues like healthcare or, of course, military design or anything that they thought would keep Germany at the forefront. And so they were really willing to consider other approaches to research and new topics and new subjects, and that was really, really important. Adding to this were a couple of players at the time who didn't call themselves psychologists. So the first one, for example, Hermann von Helmholtz, was actually a physicist. He called himself an empirical philosopher, which is coming pretty close to psychology. But he was also an ophthalmologist, and he had major contributions in all of these fields. What he did for psychology was to really show that some of the issues related to the machinery of the mind, issues that previously people thought you could not study scientifically, he showed that if you're clever, you actually can do this. And I want to demonstrate his approach with a more general example of one of the issues Helmholtz was very interested in, and that's the speed with which neural tissue transmits information. Okay, neural transmission rates. Now, previous to Helmholtz, people assumed that neural transmission happens so fast that it's immeasurable. You just could not scientifically study it. But Helmholtz came up with a bunch of different techniques. So he did a bunch of animal research and other things, but I want to highlight a logical approach that he took. And I'm going to highlight it with this example. So imagine we had Helmholtz's problem. We wanted to know how fast a neural signal could move from this lady's left hand up to her brain and then to her right hand. So specifically, imagine we said, okay, we're going to squeeze your left hand, and when we squeeze your left hand, we want you as quickly as possible to squeeze your right hand once you feel that. So the signal has to go to her brain, she feels it, and then she has to send the signal down to her other hand to squeeze. How fast can that happen? Well, if you try to do this with a single individual, the measurement, the timing apparatuses they had in Helmholtz's day simply couldn't record speeds that fast. But imagine the following. Imagine you're on a set of roller skates, and we find 1,000 people, and we line them up. And we just give them this simple task. We say, okay, here's what's going to happen. I'm going to squeeze this gentleman's left hand. And when I squeeze his left hand, I will start my stopwatch. And then off I'm going to go on my roller skates, down this hill. We've cleverly positioned ourselves on a hill so we can go really fast. So we go scooting around this hill, around to the other side, past 1,000 people, and then we go to the last person in line and we hold their right hand and we wait for them to squeeze our hand. And when they squeeze our hand, we stop the stopwatch. Okay. Now what we've done is taken this really fast thing, but by multiplying it by 1,000, having it have to go across 1,000 people, we've made it much slower. We've made it measurable. And what Helmholtz found is if you just took the total time and then you figure out, okay, what's the average distance of neural tissue in the average human being, which you can measure easily enough. And so if we now divide that total time by the average amount of neural tissue multiplied by 1,000, because we had 1,000 humans, we can derive a time. And Helmholtz did this. His time was about 25 to 38 meters per second. Again, a little rough, but hey, he could measure it. And that was the really important point. These nerve cells are the machinery that the brain is using to communicate with the body. And Helmholtz showed you could measure and study them scientifically. Very important. In the same vein, but perhaps even more important, is the contribution of Ernst Weber. Again, mid-1800s was when Weber was probably doing his best work. Weber liked the following kind of procedure. He would present stimuli, he would present two participants, two different stimuli at a time. So imagine two lines, and give them very simple tasks. Which line is longer? Now, it could also be which sound is louder, it could be which light is brighter, it could be which touch feels like it has a little more pressure to it. He studied all sorts of sensory stimuli, and he found this really fascinating truth, or law, I guess you would call it, which went as follows. He was interested in how different you had to make, for example, the lengths of a line before people could see the difference. Okay, so the first thing he found out is that our sensory stimuli have limits. Okay, we can't take one line and just add a little tiny bit to it and people go, oh, there it is. You have to add a fair amount before they notice that the two lines are different. How much do you have to add? Well, Weber called that amount something he called the just noticeable difference, or JND. That was how much extra length you had to add before people could tell the difference, or how much extra sound, loudness, how much extra brightness, etc. And what he found is that that amount, how big that amount was, depended on the original length of the line, or the original, more general terms, intensity of the stimulus. So let's look at this formula. He said if you had some original intensity, and you ask, how much of a change do you have to make to that before people notice it? That there seems to be this constant ratio. So let me explain that. Let's say this was a 10 millimeter line, and we kept making this one bigger until people suddenly said, okay, I can now perceive. In my mind, I can see those are different. And let's say we had to add 2 millimeters to do that. So they could tell the difference between a 10 millimeter line and a 12 millimeter line. Okay, so we found 2 or 20% extra. Then they could see it. What if this was now a 100 millimeter line? Well, if you presented a 100 millimeter and 102 millimeters, they still couldn't see the difference. So it's not a question that we can detect a 2 millimeter difference. Rather, you had to keep increasing this until you got to 120 millimeters. That is 20% more than the original size. So when you got to 120, now people could see it. So he found these, what we now call Weber fractions, these ratios that hold true for our different sensory systems. And the really important point of all this for psychology is that he was actually studying people's mental perceptions. He called what he was doing psychophysics, studying the physics of the mind. And what he showed is that, hey, you know what? Math seems to work. We can apply math. There are things like constants to perception. And again, that suddenly, in this environment where people were willing to explore new research methods, these sorts of findings suggested, you know what? The mind is open for study. We can have a science of the mind. So they really opened the door. Now, who walked through the door? Well, that's Wilhelm Wundt. Wilhelm Wundt is credited as being the first psychologist. That's on two bases, really. He established the first experimental lab devoted to psychology in 1874, and he wrote the first textbook over here, The Principles of Physiological Psychology, in 1879. So those two things give him the title, the first person to really call himself a psychologist and the father of modern psychology. Now, from its birthday, psychology started to have this battle in terms of science. So specifically, Wundt really favored a procedure that he called introspection. Introspection literally means, spection, to inspect something, but to inspect inward, to kind of inspect the contents of your consciousness. So this is what Wundt did, and this is what he trained people to do. He had so-called trained observers that he would teach the proper way to kind of both look into their mind and to report what was going on in there. And so he would train these observers quite heavily, and then he would present various stimuli. They could be just colors or sounds or anything really. And these people would have to tell Wundt what they were seeing in their mind or what they were hearing or anything that was going on in their conscious mind. And what Wundt was really after, it's now we call it structuralism, was that idea of what conscious experience looks like. What's the structure of conscious experience? Now, a lot of scientists didn't like introspection. They thought this was problematic because Wundt was no longer directly studying the thing he was interested in, the structure of conscious experience. He required his trained observers to look for him and accurately report what was going on in their mind. And a lot of people questioned whether anybody could really do that. And whether things like, making it verbal changed the whole experience. And so suddenly there was this little controversy over the techniques Wundt was using and how scientific they were. And that was kind of going on, and yet, Wundt still continued on and found a lot of interesting things. However, then something happened. One of these transformational figures, Darwin, of course Darwin transformed all of science. What he did to psychology parallels what he did to biology, and here's what I mean by that. When Darwin was on the Beagle, he was collecting specimens from exotic places. This is what a lot of biologists did during Darwin's time. And so he was collecting all these specimens, and then he was behaving in the typical biological way, which was he was bringing the specimens back, and then he was trying to put them into taxonomic categories. So, we think of things like birds versus reptiles and that kind of thing. How did those categories come to exist? Well, biologists would look at the features that some specimen had, and then they would group different specimens according to their features and ultimately create some class around that. Now, that's all well and good, but Darwin made another mental leap. He said, you know what? We're focusing too much on what the features are and classifying in that way. But there's a whole other very interesting, more interesting story to this. And that is, we should be asking why the features are the way they are. So of course in his famous work he focused on finches that he found in the Galapagos, and he made a big deal out of things like their beak shape. So he noticed that, for example, some finches, like this one, had sort of short, stout, strong beaks. Other finches had much longer, thinner beaks. The longer, thinner beaked finches tended to live in places where there were insects within, wooden logs or other places where the bird had to get in to get those insects. So the long beak helped them get the food. Other finches, like this one with the shorter beak, tended to live in places where there was lots of seeds or nuts. So these beaks helped them crack the seeds or nuts. So the feature of what the beak looks like is not just coincidental. It's not just random. It's very much tied into the context that the animal lives, and it has a very distinct function. And so Darwin essentially told the biological community, don't worry so much about what things look like, worry about what they're good for. What's the function? That's the real interesting story. That mentality came into psychology. I told you that Wundt was very interested in the structure of conscious experience. Well, following Darwin and heavily influenced by him, William James, now we're seeing psychology broaden out of Germany and coming into America here. William James was interested in the function of various psychological processes. So he changed the whole dialogue away from what does conscious experience look like. And instead, he's a fascinating guy, William James. He would essentially, this is my image of him, experience life, sit in a chair, reflect on things like, how does memory work and what's it good for? And what about attention? What does that do for us? And conscious experience and will. What is the human will? Do we actually control our own behavior? So he would think about all these deep issues and he would come to these theoretical stances on them. And the really creepy thing, and I do think it is creepy, is how accurate the guy was, in the sense that William James himself did not do a lot of empirical research. He mostly generated ideas. So in some ways he was more of a philosopher than a psychologist, but all of his philosophy was about cognitive things. And so he came up with all these ideas. Years later, we're doing all these experiments, and it really is uncanny how much our experimental data seems to match a lot of James's ideas. So he's a fascinating guy, and I'll include a link to the Principles of Psychology, the full text, which is his textbook in 1890. And it's kind of interesting to look through that, and it's not coincidental here that you see it right beside Darwin's Origin of the Species. That's really, these two do go hand in hand. So he really changed the direction of psychology towards this functionalist mentality. All right, so that's where we're going to leave the story for now, except I really want to emphasize the following. Up until now, psychology has been a very young science trying hard to be scientific and trying to really, promote we can scientifically study the mind. Keep that in mind and bring that with you into the next lecture on Freud, where you'll see Freud messes things up totally. In the meantime, I've got a couple of videos you could choose to watch here. The 3-minute history of psychology is just that. It's a real quick history that'll cover everything we go through. A long biography on Darwin. Darwin's just a critical figure. And I do have a link to the text for the Principles of Psychology. And I encourage you to just check out a section or two. The wording is very Victorian, the style of writing, but just to get a sense of how James thinks, I think is worth the effort. All right, so I'm going to leave it there. I will see you on part 2 of history. Thanks. Bye-bye.